Okay, so we'll just finish this one. So we're going to do the log of x to the base 3. So it has the same idea as the one we just did. So we have our log function that looks like this. So anywhere there is an x now, I replace it with my base. With my domain. Sorry, it's very early in the morning. So everywhere there should be an x, I have my domain, whatever is in the domain. Again, the power comes to the front, so it ends up being 0 times 1. It ends up being 1 times 1. So remember, the power goes to the front, and matching log and base is 1. So that's where I am getting those numbers from. 3 to the front, matching log and base is 1. So 0, 1, 2, and 3. And then I put my domain and so I put my inputs and my outputs together. 3 to the power of 0 is 1, so 1, 0. 3 to the power of 1 is 3, so 3, 1. 3 squared is 9, 9, 2. And then 3 cubed is 8, 3. So we'll graph that. 1, 0. So I'll do it in a different color. So 1, 0. The next one is 3, 1. Then we have 9, 2. Then we have 8, 3. No, it is. No, that's not 8. Sorry, that is not 8. That is 3 cubed. I was doing 2 cubed there in my head. 3 cubed should be 3 by 3 is 9 by 3 is 27. Sorry, 27, 3. So I go to 27, 3. Now, where are we? 27, yeah, at the very end here at 3. Okay, so again, a log should look kind of like a branch of a tree, which it does. The question was, where are they equal? So where is one of them equals to the other one? So really what that means is, where do they intersect? So where do they intersect? Well, they intersect at 1, 0. 1, 0. So that's the only place that they do intersect. Okay, and then what about transformations? Again, the good news is the transformations works in the same way that we've really been talking about for the last few lessons. If the change occurs within the bracket, it's a left or right movement. If the change occurs at the end, a plus minus, then we're talking literally putting it on a different shelf. You're translating it totally up, putting it totally up, totally down. And then if the change occurs in front of the log, then that branch is either getting more steep really or more shallow. So it's exactly the same as every other function we looked at. So the transformations initially, when you look at that cheat sheet on transformations, it looks like a lot, but then as you go through it, it's actually much easier than it looks. So let's have a look at these diagrams here. So the blue one is the original one. So that blue one here on screen is that graph. Okay, that's just your kind of regular graph. Now, if you compare the yellow to, we'll do green. So if you compare the yellow to the green, the only difference is something has changed in the bracket. So it was x and it's now x plus 1. Now, if the change occurs in the bracket, it's a right or a left movement. And how do I know if it's right or left? Well, if it's plus, it's actually going left. I know that kind of goes against what your brain is probably telling you when you think plus, but it is going left. So the blue graph goes left 1. So we'll just zoom in here a second. So if you look there, and if I go left 1, it ends up there. So that makes me know, or that lets me know that the black graph is the one that we're talking about. So it's going left 1 unit. You can pick other points on the graph as well. Like if you pick this one up here at 4, 2, does that move 1 left? It does. There it is, 1 left. Okay, and you can do it up here as well. It's 8, 3. If you go 1 left, it's there. So no matter where you go on the graph, you're going one to the left. Now let's have a look at the other one. So what's happening in this other one? So here we have a change happening in front of the bracket. So I'm talking about the pink one. So the change is not happening in the bracket. It's not happening at the end, you know, something plus or minus. It's happening in front of. And on top of that, notice that it's a fraction. Now, if this was a straight line, like for example, a half x, we would have talked about one line looking like that, and then a half x, we would say the slope is more shallow because your rise is only 1, but your run is 2. So we expect it to be more shallow. Now, when we're doing logs, the same thing really does happen. In other words, all the y values get halved. So the red one is the pink. The red one matches up with the pink graph. So all the y values get halved. And you can see that actually in the graph. So first of all, it's more shallow. So I think, you know, we have that concept now from when we looked at the line. But also, if you just look in detail here, the y value for the blue is 1, and the y value for the red is a half. So do you see the way the y values have been halved? Here, the y value is 2 for the blue. For the red, it's 1. The y value has been halved. Here, the y value is 8. Here, for the red, no, the y value is 3, sorry. The y value is 3. And here, the y value is around 1.5. So everywhere along the graph, you can see the y value is being halved. That is why it is more shallow. But if the change occurs in the front and it's a fraction, it's more shallow. If it's a whole number, it becomes steeper. So in our case, that's why it is that way. Let's have a look at doing one for ourselves. It says this is the graph. It is being shifted to the left by 4 units and shifted upwards by 2 units. Now, the minute I hear right or left, I immediately know that the change occurs in the bracket. So instead of just x now, if I'm going left, it's plus. I'm going left 4 plus 4. It also says it is being shifted upwards by 2 units. So after I do the log, I have to do plus 2. So I do the log of x plus 4 to the base 4 plus 2. And that is the transformation. And that was the last one, was it? Yeah. Okay.